Okay. Oh, I should start streaming. It's probably be blocked by the firewall. Not this time. Went right through.
Why is it sometimes blocked by firewall?
I don't know. Keep asking that question. Okay. So look, here's what we're doing today. We're going to talk about your grades. So I have lots of zeros, but it could be because I haven't graded some stuff, but it's probably not because I'm pretty much caught up if it's turned in on Schoology. So major grades make up 60% of your grade. That means that if you have not done the PowerPoint Google Slides, that is more than half of your grade. So you should take a look at that. And if you didn't get a grade that you like, you should totally fix it, and I'll just take 10 points off. So, you know, get it done, do it right. I gave you the rubric. You can check and see what grade you get in. And if you're confused, there's a little rubric button on Schoology. When you see your grade, it's little 4 little squares. You can click on it, and you can see where you got points, and you can fix it. Sound good? Sound terrible? Mediocre. Mediocre. Got it. Okay. And then there's 3 daily guides in the gradebook right now. The Humans Do Not Apply quiz, the ASCII art, and the discount calculator. So I kind of take everything from Schoology, and I just kind of pick and choose which ones work. And then if I have holes later on, or I need to get bonus points or something, I'll probably just fill in some of the other stuff. So you should totally do everything, but that's explanation of why what's in there is what it is in there. Okay, let's talk about how to pass information. I'm gonna draw some pictures. You ready for it? I got some mad art skills. I almost decided to use Photoshop, but then I decided Paint would be so much better. Just draw. Let's draw a wire. There. Isn't that a great wire? Best wire. All right. If you have a wire, how do you transmit information across the wire? Huh? Okay. Buzz. How did that transmit information? Okay, let me rephrase that. He just said electricity, which is fine. But when you send electricity on the wire, it goes, whoa, that's a line. Well, that's probably fine. No, it's not. Look, I'm going to go all pro. Bzz, bzz, there's my electricity bubble. Right? So you say transmit electricity, but I go bzz, dunzo. How did that help? I just shocked you. How do you transmit information? Do what? How do you get the coded information? You have a wire. How are you going to transmit information? Sure. See, you guys are like throwing out all these technology answers. I'm going to be like, of course, you're right. But look, how do you send information on a wire? Let's do a better example. Let's suppose this is a piece of string instead. And then let's suppose, ooh, that's terrible color. Let's suppose, solo cups. Let's suppose we get 2 red solo cups and we tie them to the end. Can I transmit information from one end of to the other with 2 cups and a piece of string? So you're talking to it, and what are you sending? Well, you don't have to yell. Physically, what happens to the string? You're sending vibrations, right? Because those vibrations make airwaves, and when it goes to your ear, it turns into sound. Yes? And so you can actually make the vibrations with your mouth. The cup grabs it, right? Passes it onto the string, and it goes all the way across, and the vibrations come out this end. And then your ear turns it into sound. Yes? Am I like in your world of reality right now? Because I really want you to understand this, so I'm going to go to where you do understand, and we're going to build back up there. All right? So, you talk into a cup, and when you talk really loud, let's do like, what do you want to do, like a blue? When you talk really loud, it vibrates a lot. But then you got that annoying kid or friend, and they just like breathe in the cup. And it's so super annoying. Yeah? Okay? What kind of vibrations are they sending when they're just breathing in the cup? Small little vibrations. Like that. And then they start talking again. Talk, 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 talk. And then they breathe. And then they talk. Right? And then they breathe. So far, so good. Everybody with me? All right. So let's go back to our little wire. Make it black again. Maybe gray. Gray might be more fun. Can y'all see my gray wire? No? All right. So let's say this is a wire, and I want to send electricity this time. Do you think I could send electricity the same way that I sent this? Maybe. Let's do a box. We'll do like a solid color outline, solid color fill. Let's see if I can get this all pro. So maybe, I send a lot of electricity, right? And then I send a little bit of electricity. And then I send a lot, and a little bit, and a lot, and a lot. And if I got you, if I got you on a beat, going do 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 do, then you would just be able to know that every beat you just gotta check to see if you're getting super shocked or just kind of shocked. Right? Y'all following that logic? I want this to make sense. We're good? Yes, no? Okay? So all I really need is a device over here. What does this device need to be able to do? Okay. To send, or like electric pulses, electric charges, right? Did you ever like see a word and think, did I spell that right? Electric's right now. Did I spell electric right? Pretty sure. That's electric. Yeah, if you start looking at any word, like needs, if you just look at it for like 3 minutes or so, it just starts to look misspelled out of no reason. I'm gonna keep going. Send electric charges at 2 levels. What are the 2 levels? High and low. So then, we're going to have little arrows here. Arrows! Charges go this way. So then over here, what do you need? Okay, I need a device that what?
Picks up the electric charge.
So it can receive it. I before E, except after C. There we go. 2 levels of charge. Does that sound good? Cool. Well, now what are we going to do with this guy? Probably want to save that information, right? Like a hard drive or USB or something like that. Okay, let's draw that. Yuck, there's a little black dot there. Not anymore. Okay. Here's the device. Let's draw what it looks like inside. How would you save this? How do you normally hold a charge? Starts with a B, sounds like battery. Seriously, guys. Starts with a B. Battery! A little capacitor, something like that, right? Yeah. So we're just going to have a bunch of little things. We're going to go charge, 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 charge. 1, 2, 3, 4, 5, 6, 7, 8. We'll do 8. There's something special about 8. And then we can hold lots of groups of 8. 2. So far, so good? And my device, which I don't have to talk about, but it's outside of the scope of this class, will decide that this guy is a high, and this guy is a high, because high, low, high, low, high, high. Yeah? And we do low, low for these. And then we can take, like, this color, and be like, oh. There you go. Oh, color coordinated. So good. Now, to give you vocabulary that I'm sure you've heard, one of these, oh, that's in yellow. There you go. One of these is a bit. It's a 1 or a 0. High or low, on or off. But we don't actually ever turn it off because if your capacitors ever lose their energy, then it's really hard to get back all the energy in. So we just stay low. So this is a bit. And when you have 8 of them, whoa, no pill. When you have 8 of them, what do we call it? Nom nom. It's a byte. Right? So when you see like that a file, when you see a file size that's a kilobyte, it's 1,000 groups of 8. When you see a megabyte, that's 1,000,000 groups of 8 on-offs. Right? A gigabyte would be a billion, and a terabyte would be a trillion. And to give you more references, a terabyte would be like 1,000,000 megabytes. So it's interesting. We always talk about like megabytes in our storage space, but when you look at your internet speeds, they talk about bits per second, megabits per second, because they could say it's 8 times faster than it would be with bytes. Because if in the time that you send 1 byte, how many bits are you sending? 8. Because there's 8 bytes or bits in a byte. Right? So if you ever look at internet speed, everybody else talks about megabytes in terms of space, except internet providers, and they talk about megabits because they want it to look like they're doing more. Okay, and then what we're going to do here is we're going to say if it's a high charge, it's a 1. And if it's a low charge, it's a 0. And now we can do math. Text and pictures and all kinds of other stuff. Have y'all heard this before? Is this new? Kind of? Is any of this new? Have y'all done binary before? No? Well, let's do it. Let's look at the math system behind it. Good? You ready to write? All right. We can all use 1s and 0s. We're going to figure out a counting system that only uses 1s and 0s. Are y'all ready? What's the first number I can use? 0. Got it, boss. Next. Okay, I'll take a 1. What comes after 1? Well, that would be the same number. I can only use 0s and 1s. What's the next number in the number system that comes after that only uses 0 or 1? 10. Then what? Oh, wait, there's one you're missing.
11.
Ah, yes. 11. And then 100. What comes after that? Okay. 110. 111. Do I do 1,000? Is that my next one? I mean, everything else is going to have 2's in it or something, right? Here we go, 1,000. Well, all right. Well, now what? 1,001. 1,000, what, 10? 1,011. Then what? 1,100, yeah. 1,101. And 1,110. 1,111. That's pretty good. Okay, so this is our binary. Let's do our decimals. Some of you are like, decimal? I don't want to put no points down. That's silly, because we call our system the decimal system. So the way that you learned to count in kindergarten or first grade, that was the decimal world. You just didn't even know it. It's like fish don't even know what water is. So they suck it. Then they know what water is. Anyway. So, you okay if we assign 0 to be 0? Am I going to have a beef with that? I have had that happen. Students like, no, 2 0. What should we do? The 1 should be what? 1. What's this going to be? What comes after 1? Well, I would usually go with 2. Are we cool with 2? What comes after 2? Then what? Y'all 6, 7, 8. Y'all okay if we just fill this down? Yeah? Alright. Hey, look. It's binary. And we got a little table to show us what's what. So, you know, trying to show off to folks you got skills to pay the bills. You're like, I can convert binary to numbers. But surely there's an easier way, because we can't make tables forever. That would just be terrible. You who only goes to 9? Yeah, then we go to 10. I did. That's it. Am I missing something? Ah! You could. It would get really chunky. It gets really like busy. Because how are we supposed to know, if you do 1 and 0, how are we supposed to tell the difference between this 1 and 0 to make 2 and the one to make a 10? Like if I write down, y'all see what he's saying, right? He said like, you don't need any of this. But what I'm saying is if you want to make 10, how would you know the difference between 1 and 0 for the 2 versus 1 and 0 for the 10? Does that question make sense? Which is why we got to keep adding with this number system. All right, let's see if we can figure out a way to like solve it. So what is 1100? Look on your table and tell me what is 1100. Okay, so that's 12. But let's see if we can do some addition. What are two numbers that add up to make 1,100? Don't let me down. What are two numbers that add up to make 1,100? 1,100. Yeah? 1,000 plus 100. What's binary for 1,000? Like when I have 1,000 over here, what number was it? What's the decimal for it? 8. And what's the decimal for 100? 4. And 8 plus 4 makes 12. So apparently there is some logic behind this. Yeah? Okay. So let's try another one. Let's try this. 1,110. What's that supposed to make up? Do what? 14. Sounds good? So what do you... Let's add up 3 numbers to make 1,110. What 3 numbers would you recommend? 1,000, what? 110. And that will make my 1,110. So something should make 14. Let's see what we got. So the 8,000, or sorry, the 1,000 is an 8. Yeah. The 100 is 4. So far, so good. And the 10 is 2. And 8 plus 4 plus 2 is 14. It's cool, right? However, there's a secret trick. Would you like me to show you the secret trick? Here we go. One, 2, 4, 8. Y'all can see this, right? 1, 1, 1, 0. So you start over on the far side and you write 1, and then you just keep multiplying by 2. And if there's a 1 there, then add that number in. So 8 plus 4 plus 2. 4. Unless you think I'm crazy, pick another one. That may not help with the crazy thing, but we're going to make it as example. Would you like to do 11? Can I do 11? Does that work for y'all? Yes? No? Yes? Okay. So what's the binary for 11? So we go 1, 2, 4, 8. So we're going to add up to 8 plus the 2 plus the 1. And that makes 11. It's nifty, right? I guess so. It's 8. Can I go the other way? I mean, you know the answer is yes, right? We just got to figure it out, yeah? Let's do it. Give me a number. Less than 50. 25. Is that what you said? All right, 25. So here's what we're going to do. I'm going to start counting by multiple powers of 2. So 1, 2, 4, 8, 16, and I'm not going to do the one when I get bigger than the number I'm looking for. So 32 is the next one, right? I don't need that one. So 1, and then I go backwards and start labeling them. 1, 2, 4, 8, 16. And now I need to figure out which numbers add up to 25. And there's only one combination that works. So if you have a number that's big enough to use, then you should use it. So, do I need the 16 to represent the 25? Yes. And then what I can remember up here is I can say 25 minus 16 is 9. So if I get this is 16, if I can get all of this to be 9, then I'm good. Right? Because then 16 plus the 9 would be 25. All right. So do I need the 8? Yes. And I can know that 9 minus 8 is 1. Do I need the 4? No. Do I need the 2? No. Do I need the 1?
Yes.
And you can go 16 plus 8 plus 1 is 25. Nifty, yeah? It's not as complicated as you probably would have thought, huh? Would you like to try one on your own? Yes, no, maybe? Big maybe. All right, here. Look, I'm going to fill out this all the way up. This 64, this will get you all the way up to 100. 32, 16. So if you need a template, here you go. 8, 4, 2, 1. So if you need a template, there's a template. I want you to do 2 problems. I'll give you like 2 minutes. First, I want you to do 1, 0, 1, 0, 1, 0, 0. I want you to tell me what that equals. And then I want you to find the binary for 70. So you're going to figure out what this binary number is, and then you're going to find the binary for 70. Hopefully I didn't give you 70. Nope, I didn't. Because that would have been awkward.
I already got it.
Good.
Mm.
So I want you to write it on your paper. I'll come around and look. I'll give you like 2 minutes. String will be right back.
How many people are in the school?
Why not? But the nice thing is supposed to be just pull it up every once.
Let's do a full thing about you can drop by whatever you want.
You ready? Yeah, you. You all writing on paper? That's the big- Fill in your eyes. Okay. You write this down. Put the one above it. Zero. Put zero in the next one. One. Zero. One. And everything with a one, we have divided by zero. One, zero, one. Is that okay?
I don't know how this works because it doesn't equal to me.
You good? Good. So figure it out? What is it? Go to 84. Maybe. Because this is 64. This is 16. This is 4. So 64 plus 16 plus 4. 84. Yes? Good? Mhm. And then 70 would be 64 plus 4 plus 2. Right? So you would have a 1 in the 64 spot, no 32, no 16, no 8, 4, 2. I only got 2 other things to show you. addition and multiplication, which are surprisingly easier than you would think. Are you ready? Yeah, ready? 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 All right, y'all, check this out. Be ready to impress someone. There you are. That might not be how you guys impress people, but I flex my brain muscles. So, anyway. All right, let's add. I don't know. You're gonna add like plus 1, 1. Let's do that. That looks good. Okay, we're gonna do just like regular addition. What is 0 plus 1? 1. What is 1 plus 1? You are not allowed to write that. How are we supposed to write 2? If only there was a way to write 2. We'll do it. 0 and carry the 1, just like you learned earlier in school. Right? 1 plus 0. 1. Carry the 1. Yes, sir. Yes, sir. You all good? Should I do another one? Oh, sure. 1, 1, 0, 1, 0, 1. Plus, what do you want to do? There you go. 1 plus 1? 10. 1 plus 0 plus 0? 1 plus 0? 0 plus 1? 1? It's easy, yeah? Like once you know how to do this piece, where you turn the numbers into binary, the addition's like cakewalk. And we're about to do the most time-consuming part, which is far easier. Here you go, bud. Oh, I just signed it. You filled it up. Okay. There's one this way past the nurse, or there's one over there by the auditorium. Be sure you take the clipboard by the door. All right, you ready to multiply? You're gonna feel so smart. I promise. It's gonna be great. Let's multiply these numbers. Oh, that's good. All right. 1, 0, 1, 0. Let's do 100. Let's do 101. Yeah. All right, we're gonna multiply, just like elementary school. I promise. What's 1 times 0? What's 1 times 1? 1. What's 1 times 0? What's 1 times 1? And then, just like in elementary school, you always put a 0 there, right? Yeah, I like to put a little dash, so I don't get confused by 1s and 0s. What's 0 times 0? What's 0 times 1? What's 0 times 0? What's 0 times 1? And then the last row, we're going to put 2 dashes. Yeah? What's 1 times 0? What's 1 times 1? What's 1 times 0? And 1 times 1. And then just like in elementary school, what did you do after all that? We added up. 0, 1, 0. That's 10. Look how easy it is. And the trick, you already see the magic trick? You ready? Ready? If I take this over again, the magic trick is you take every one and you just start on the second row and you start writing that number below the 1. So 0, 1, 0, 1, and then directly below this one 0, 1, 0, 1. And you don't have to multiply anything by 0 on the second row because that's just ridiculous. And then you can just add it. Same answer. So to help you, like, I hope this helps you see. So I do like 1, 0, 0, 1, 1 times we'll do 101 again. That's fine. So all I would do is I would start a line here, and I would start a line here. So 1, 1, 0, 1, oops, 0, 0, 1. It's a perfect copy of the top line. Yeah? 1, 1, 0, 0. And then you add it. Easy peasy. 1, 1, 1, 1, 1, 0, 1. Okay. Do you have any concerns? Have I taught it? Okay? You understand it? Alright. Here's what we got today. I hope we did that. I'll bring that over. Bam. Alright. So here's what I need you to do today. First, take the binary quiz. It's in Schoology. You got this. Second, this right here, where we at? This right here would be like your practice assignment. It's in Schoology for you, but I typed it out just so you can see it. So these 4 things is what I'm looking for you to do. So on paper, feel free to do it. If you're online, you can take a picture of it to submit the handwriting. I'm looking for these things to be done. It's actually 8 because there's 2 of each of them. You gotta take these numbers and turn them into binary, turn these numbers into decimal, add these 2 in binary, add these 2 in binary, and then multiply the same numbers. And then any zeros you have in the Humans Need Not Apply quiz, the ASCII art, the discount calculator, the Humans Need Not Apply update, take care of those.